So next I will start this metal casting and welding, subject code 18ME35A. So lecture 2. So last number, so today I have given one lecture 1. So next part, remaining portions I will cover in this lecture number 2. So in this session, so I will cover pattern allowances. So first thing, what is the necessity of pattern allowances? Why it is provided in the pattern allowances is necessity for preparing the pattern at the time of preparation of the pattern. So the pattern allowances is, first you can pattern. What is pattern? Pattern is a replica of the object to be cast. So it is a slightly larger in size for few reasons. The increase in size of a pattern is called pattern allowances. So pattern which helps produce the good quality of the casting. No number of patterns can be designed without these allowances. So types of allowances. So there are important types of pattern allowances. The first one is a shrinkage allowance, masking allowance, drop or taper allowance, distortion allowance, wrapping allowance. So these are the important pattern allowances provided before preparing the patterns. So first one is what is shrinkage allowances? Shrinkage allowances, almost all metal shrink or contract volumetrically after solidification, and hence dimensions of the casting becomes smaller than the desired or requirement. So to avoid this, the pattern must be made slightly, very small amount of slightly larger or bigger in size to compensate for contraction or shrinkage of the metal. So you can see this figure. So you can see this is a mold cavity. This area. After solidification, to shrink the molten metal, this left and right side, you can some slightly gap is there. To at the time of solidification, to shrink the molten metal. That's why the slightly larger than the required metal can prepare the pattern. It is called as shrinkage allowances. The metal shrinks depends upon, first reason is the cast of the metal or alloys. Second one is a pouring temperature of the metal or alloy. Third one is a casted dimensions, size and shape. On that basis also to shrink the molten metal or liquid metal. And fourth one is a molding condition. That is the mold material and molding methods employed. Mold materials means either it is ferrous metal or non-ferrous metal, and different types of molding methods. Molding methods are used. So depending on that. So next we can go for the typical shrinkage allowances for the metal pattern. The standard value is given in the table. So first we can see the metal, different types of metals or alloys used: cast iron, brass, aluminium, cast manganese, lead, steel, copper, and malleable iron. So these are the different types of materials used in the boundaries to preparation of the casting. So we can see the shrinkage allowances, the standard value is given. So mm per 100 mm per 100 mm. Suppose example, you can take the cast iron is 1, brass 1.6, aluminium 1.6, 2.6, lead is 5.4. This is a major value. So steel is a 2.1 and 1.9 copper. Malleable iron is 1. These are the standard value to maintain the pattern allowances at the time of preparation of the pattern. The pattern shrinkage allowances is provided at the standard values. You can see that 1 is a minimum value. Suppose you can example, you can take the cast iron is 1 and malleable iron is 1. So maximum value to the liquid metal sinks at the time of solidification is a 5.4. The material is lead. So remaining almost all 1.5, 1.6, 1.22 in between that. Maximum value is 5.4. Lead is a maximum shrink at the time of solidification, and cast iron is a minimum, and malleable iron is a minimum at the solidification to shrink the liquid metal. So you can see here liquid shrinkages. So before we can put the molten metal in the cavity, After solidification, some gap will be provided in the left and right side and bottom side to shrink the molten metal at the time of solidification. That's why the shrinkage allowances provide before before preparing the pattern. So next, second one is a machining allowances. So machining allowances, a casting is given an allowances for machining because of axis dimensions of for the casting is called machining allowances. Dimensions means, suppose example 10 mm, so you can take a 11 to 12 mm, you can put on the pattern. So the axis material, axis dimensions of the casting is called machining allowances to remove the extra amount of material as per your requirement. So machining allowances in addition to shrinkage allowances is given to the pattern. Casting get oxidized in the mold and during the heat treatment, extra oxide layers, scales, etc. thus formed need to be removed after solidification. Second one, it is intended to remove the surface roughness. Surface roughness you have to remove other imperfection from the cast part. Third one, it required to achieve exact casting dimensions. It required to achieve exact casting dimensions. Surface finish is required of the casting. So next, for fifth one, machining allowances depends on the following on the factors listed below. So nature of metal, size and shape of the casting. Depending upon the size, it's very important role. So the type of the machining operations to be employed for cleaning and casting conditions and molding process, different types of molding process, which type of molding process is adopted, that's a very important one. So machining allowances of the various metals, the standard table, the standard values are given. So first you can see the cast iron, aluminum, some examples, cast iron and aluminum and cast steel. So here dimensions in component size 0 to 300, there are two categories, 0 to 300, 300 to 600 in mm. So machining allowance is given 0 to 300, 2.5. Suppose the cast part will be, the dimensions is more than 300 to 600, you can, machining allowance is given 4. Aluminum you can see that is a 0 to 300, 1.5 and 300 to 600 the machining allowance is provided at 3. Suppose you can take a cast steel, so 0 to 300 dimensions to the cast part, so the machining allowance is provided 3 mm and 300 to 600 so 4.5. These are the standard values machining allowance is provided on the pattern. So depending on the material to change the pattern allowances. So next, drop and taper allowances. Drop or taper allowances means it is not a taper, means it is a vertical shape. Drop allowances is given so that the pattern can be easily removed from the cavity in the material. Tightly packed around it without of damaging the breakage or damage of the mold cavity edges. It can easy to remove purpose drop allowances provided in the pattern. The amount of taper depends upon shape and size of the pattern. The shape and size will be, it is very important, and direction in contact with the mold cavity. So you can see in this figure. So this is the taper, means some small angle is provided here. You can see that this is a vertical shape. So this is the taper allowances is not provided without taper. This is the taper allowances provided. So molding methods, second one. Third one is a molding material. So you can see this figure clearly understand the taper or drop allowances. Next one is a fourth one, distortion allowances. So casting having a shape such as C shape or U shape and V shape lose their shape during the solidification. Sometimes you can lose the shape. C shape is required, but at the time of solidification, C shape you lose the shape of the C or U or V, etc. The loss of shape is referred as distortion. The loss of shape is referred as distortion. At the time of solidification, the shape lose the shape during the solidification. The loss of shape is called as distortion. To take care of this, the pattern is given allowances in the direction opposite to the expected distortion. This is referred as a distortion allowances. So you can see that before and after the two figures of the shape will be changed. Shape lose the shape before, after, and before and after. So next you can go for shake and wrapping analysis. This analysis is provided the pattern compensate for enlargement of the mold cavity because of over shaking or wrapping. Shake loss is normally provided only the large casting, small and very small and medium size casting. The wrapping loss is not necessary. The bigger size casting is required. So mold work cavity is prepared. The wrapping losses or shake losses is very important role because of it negligible in case of a small casting process. Pattern color code is there some important as per ASTM standard. So black color that indicates cast surface to be left unmachined, not necessary for machining, and red color that indicates for the cast surface to be machined. Cast after solidification, we will get the component. The component is sent to the machine shop or machines if it is required. So that indicates black color that indicates for the machining is not required, and red color is the that surface that area will be machining is required, and red strip on yellow base loose piece and seatings, and yellow color is that in the core print sheets, and no color parting surfaces. So these are the standard colors used in the pattern. Next is sand molding or sand molding sand or sand molding or molding sand. It is primary and basic material used in foundry shop for preparing the molds. Sources available of the sand, river beds, sea, lakes, etc. So ingredient of the sand, refractory sand grains, that is the base sand, and binders, waters, and additives. Before using the mold box, you can take the base sand, then some percentage you can mix with binders, some percentage mix with the additives, and some percentage of mix with the water. So in case ingredients, the base sand is nearly about 80 to 90% of base sand. Remaining 10% you can mix with binders, additives, and waters and filter the muller. I'll come there to explain the details one by one. So next types of sands used in the foundry. Molding sands are, so natural sand occurs readily in nature. So it contains all ingredients in the right proportion. The sand can be directly used in the preparation of the mold. Natural sand directly used to prepare the molding sand. Additives and binders and water content, all ingredients present on that natural sand. Directly you can use that to prepare the mold box. So synthetic sand, it is prepared mixing of different ingredients. Different ingredients means that is a sand, binder, additives and waters in correct proportions and then used to preparing the mold box. So next is types of base sand. So 80 to 90%. So silica sand or silicon dioxide, which is called as a base sand, and types of base sands used in the foundry: silica sand or silicon dioxide, olivine sand, chromite sand, zircon and zirconium silicate. Using any one of them, silica sand, olivine sand, chromite and zircon or zirconium silicate. First, you can take requirements of the base sands. What are the main requirements? It should be thermally stable. It is very important. It should be reusable. That reusable means it is again you can prepare the mold box after completion of the process. Then open the hope and drag mold cavity. You can open that. You can take the component from the mold box. Then again you can reuse mixing with additives and binders and waters. Then you can preparation of the sand. Then again you can reusability. And third one, it should be easy to prepare and control. It should have low expansion characteristics. It should have low impurities. It should have chemically inherent in nature. It should possess permeability. It should possess adhesiveness. It should be available plenty and also be cheaper. So these are the main factors. Next, go for the binders. The binders in 80 to 90% the base sand, silica sand, and the remaining 10% you can mix. Maximum minimum is 5 to 10% mix in a base sand binders. So binders is it is a material which imparts necessary binding action to the sand. That is the main function of the binders. Why it is mixed in the binders in the molding sand? The main concept is it is a material. Binder is a material which imparts the necessary of binding action to the sand. That's the main function of the binders. That's why you can mix with a foundry sand or base sand. Second one is the binders holds the sand grains together. The second important, very important function, the binders holds the sand grains together and induce the strength and other properties to the mold. The main concept of the mixing of the binders to increase the strengths, and other properties also enhance or improve. Third one is a sand when mixed with a binder is capable of taking the shape of the pattern and retaining it. It should not change the shape. Once you can put a pattern inside the mold box surrounding of that pattern, you have to fill the molding sand. Then after that you can remove that pattern. You should not change the shape of the mold. So same, it is a retain it. That's why the binders is very important 3 points to improve the strength and impact the necessity of the binding action. And third one is a shape of the pattern and retain it in the mold box. Types of binders, different types of binders used in the foundries. The first one is a organic binders. Examples, organic binders example, resin dial, mineral oil, dextrine or resin. So inorganic binders, example clay binders and bentonite. And other binders also you can use that. Example sodium silicate and Portland cement. So next go for the additives. 5 to 10% you can mixing in the base side. And additives is the minimum value is 2 to 5%. Maximum value is 5%. It's not more than that. So you can mix with the base side. So additives are generally added to develop certain new properties, enhancing the new properties like resistance to sand expansion. Example like resistance to sand expansion or to enhance the existing properties of the molding sand. This is a very important role for mixing with additives in the base sand. Second important function, in addition, improve the quality of the molding sand and hence the good casting is obtained. Very fine casting you can obtain or you can achieve. Example, you can use that Seco or silica floor, wooden floor or iron oxide. Anyone you can use that will get the good casting. Next, enhance the properties, develop new properties like resistance to sand expansion. So next, additives is not import binding qualities. Next, preparation of the sand molds. How to prepare the molds? So the molding machines are there. Sand molds. These are used to maintain a good molding casting. Consistently produce the molds at a faster rate with accurate molds resulting in a good quality casting. Types of molding machines used in the foundry. So there are 3 important machines. One is a Jolt type molding machine, squeeze molding machine, and third one is a sand slinger. These are the very 3 important machines used nowadays almost all in foundries. Manually it is a manually it is not possible to use this one. Better to on almost all small scale industry or big scale industry or modernization or mechanization of foundry. So use these 3 important machines. So Jolt, squeeze and sand slinger. So details study one by one. First one you can take Jolt and Jolt machines. So you can see this Jolt type molding machine. So this is a piston cylinder arrangement. So this is a table. This is a piston. The table is moving up and down fastly. So first you can take a mold box or drag box or cope, whatever it may be. So put into the pattern in the mold box. Sorry, metal box. Surrounding up this pattern or drag box, you can fill the sand. Preparation of the sand. Preparation of the sand means to prepare the base sand, mix with the additives, mix with the binders, some water content you mix and you can prepare that sand. The preparation of the sand you can make surrounding of pattern we can fill it. After that we can put a mold box in the table on the table. So the air, due to the air compressor, the table is moving up and down, falls to raising and down. So nearly about 50 to 20 times jolting action taking place. The sand will be completely packed around the pattern, very tightly packed around the pattern. It is called as, it is very simple mechanism. It is not a complicated. It is very simple. Only the piston movement taking place, moving upward and downward direction with the help of air compression. The piston cylinder adjustment table is there. So jolting action taking 10 to 20 times. Then main concept is sand is tightly packed around the pattern. That's the Jolt type machine. So next we can go for the second one, squeeze molding machines. Same principle. So this is a piston cylinder arrangement. Only extra thing is squeeze plate is there. You can see that is a squeeze plate. Same you can put to the squeeze machine table, and squeeze plate is impact on that sand. Squeezing action, due to squeezing action, very tightly filled with the sand surrounding of the pattern. It's a very simple mechanism. So next, sand slinger. So sand slinger, the main function, the main concept of this machine. So before the sand slinger machine, manually you can take from the sand for sand and put it to the mold box, and you can prepare the mold cavity manually. Nowadays, almost all in mechanization foundry. So the sand is taken from the sand storage tank. It is called as a sand bin. This one. Sand will be storage. Preparation of the sand. Preparation of the sand means we can put into the additives, binders, and water and base sand mix with in a muller, and you can prepare that preparation of the sand. You can put it here. This sand is carried from this point to this point through the belt conveyor. This is a rotating belt conveyor. The buckets are surrounding of the belt. These are the buckets, 1, 2, 3, 4, 5, 6 are the buckets. The sand carried from the sand bin to with the help of buckets, and put it to the belt conveyor here. This belt conveyor. Once you can, sand will be flowing from this point to this point, and easy to move and flow through the. This one is a ramming head. Ramming head. This ramming head is controlled with the help of swinging arm. It is movable in the 360-degree. This is the ramming head moving at a 360-degree with the help of swinging arm. You can see this is the swing arm is there. So inside that, this ramming head, the impeller is there to increase the velocity and pressure of the sand particles falling and the down at the time of down. So increase the velocity and pressure. With very high pressure and velocity, the sand will be moving from ramming head to the mold box. It will pulse here. Once you can fill that this mold box, then you can again supply it send to the jolting machine, squeezing machine. Then we can prepare the mold box. This is the main concept of the sand slinger machine, to fill the sand in the mold box with the help of the sand slinger machine. It is a very simple mechanism. It is not complicated. Only can carry the sand from sand bin to the mold box with the help of belt conveyor, buckets, belt conveyor, and impeller head to the mold box. So this is a simple mechanism used in the almost all in the foundry industries. You can see this one. This is a base sand tank or sand bin or sand storage tank. So this is a belt. This is a belt attached to the buckets, concave shape, and this one is a belt conveyor. Sand is moving from here to sand. You can put it here and moving from here to here. Then we can pulse the ramming head. In this ramming head, we increase the velocity and pressure of the sand particles and falls down to the mold box. Simple mechanism. This ramming head is rotating at 360-degree with the help of swinging arm. Swinging arm is there. So moving in anti-clockwise direction or clockwise direction, whatever the required position, you can set it and fill the sand in the mold box. This is a working principle of sand slinger machine.